Good afternoon. So last class we stopped here. Exercise in class 1. We are still in chapter 3, and today we will try to finish this one. Okay. Normal approximation to binomial distribution. So as you all know, we have seen that binomial, okay, if it wants to go through approximation, we have seen that the approximation can be done by Poisson. Okay. Here what we're going to do now is binomial can be also determined by approximation with normal. Okay, normal also we can do. Okay, before I go on with this exercise, see, binomial is discrete, Poisson also discrete, so no adjustment is needed in the variable. Okay, no adjustment is needed. Okay, binomial and Poisson are one type, discrete, and this we have done. But for normal, that is continuous. For you to adjustment, for you to bring discrete to continuous, you need to do some adjustment. That adjustment we call that this adjustment is known as continuity correction. Okay. So but binomial to Poisson, no adjustment needed because both are same type, discrete and discrete. But then when you want to do approximation by normal, then we have to do some adjustment in the variable because we are going to change the discrete to continuous. So what we are going to do now here is, binomial is a discrete, isn't it? Let's say single digit. Discrete means individual, but continuous, it will be in some interval. So how to make this single digit to an interval? Okay, how we going to change this? Because normal, if you notice, everything is in interval. Okay, before this, if you notice all the probability, if you want to find the probability, is in the range. It is given in the range, but this one is a single digit. Okay, we need to do some adjustment there. Okay, first time. Let's say in discrete they ask you to find the probability of x greater or equal to 4. Okay, we want to, this is binomial, this is binomial, and we want to do the approximation by normal. Okay, we want to do approximation by normal, but we cannot write here for, no, doesn't work in that way. We do have to do some adjustment because of the discrete and continuous thing. So this is how I teach my students. Put a line here, put a 4 here, and put a box. When you put a box here, this point here is minus 0.5 become 3.5. It's on 4.5. Okay, when you see there's an equal here, okay, you see a equal here, when you want to write here, and when you see equal, you write from here, which means here greater or equal to, look at the green color, from where it starts, from 3.5, isn't it? So you have to start from 3.5. Then if the question give you like this, and you want to do the continuity correction, this you have to do continuity correction. From here onwards you have to change to is at 3.5 minus something, that one you have to do. Okay, so for now we are looking at this one, greater and equal, any number, anything can. Like this there are many types. Let us do one by one. Let's say the binomial is x greater no equal okay. If I put a box, and you have to understand this is 3.5 minus 0.5, this one at 0.5, 4.5, just remember that. Yes, but there's no equal here. Whenever there's no equal, you don't need to go within the box, you go outside the box, which is 4.5. Whenever there's an equal, no inequality, like this, whenever there's a single digit equal to single digit, for you to change it to interval, you go inside the box. That would be x is in between like this. There's an equal here, go inside the, from the, follow the arrow. Suppose you have to start from 5, but whenever you have an equal, you extend little bit from back behind. Okay, take from inside the box. Whenever you don't have equal, you go outside the box. That's how you think. supposed to start from 5, but then there's no equal. No equal don't come inside from the box, outside from the box. Supposed to be from 4 to 8, but there's a equal and equal here. Go extend little bit to this left hand, right? Take full, extend the thing fully to optimize the usage of the box. This one become 3.5 and become 8.5. Can you guys guess what would be here? Maybe you can try first. No need to tell me. You try for yourself first. I will write the answer. Yeah. Oh, I'm almost write the answer. Try first. Where is the green part will be? You try yourself first. There's no equal here, so don't go inside the box. Should be here. That would be 4.5. $7.5. Try this. This one should be, there's a equal, arrow goes this side from here. No equal, arrow goes to the right hand side, don't go inside the box. Equal, yes, Intan alias. Any question? You can type here, or you can open the mic and ask.
Sorry, that can.
That cannot.
No, no question.
Now, if you notice here, there's no equal here, so you don't go inside the box, and there's a equal here, you go inside the box with the 6. So like this. Yes, Tan Yoon Ki. You can open the mic and talk to me, or you type a question in the chat, or you accidentally press the button. No reply. All right. So these are the, I suppose I covered all the patterns, all the cases for this continuity correction. So this is how you're going to adjust the discrete variable to continuous variable, to make the discrete variable to continuous variable. This is the adjustment you will do, right? Now let us go to some rules, condition on approximation. So as I told you before, binomial can be approximated by Poisson and normal. So original question will be binomial. This can be approximated by to another distribution, namely Poisson and normal. It's just Poisson is discrete and normal is continuous, the variables. For you to use Poisson to approximate binomial, okay, before that, for you to approximate any one of them, Poisson, normal, you have to make sure that first of all n must be greater or equal to 30. Okay, that is for sure. If n is less or equal to 30, you cannot approximate normally. And then for Poisson, for you to approximate, n times p must be less than 5. For you to use normal, n times p must be greater or equal to 5. The p, if is near to 0, means you can use Poisson. If the p near to 0.5 means, then you can use normal. That is the condition. And maybe another condition is, in binomial, the original value, the number is small. Here p maybe, okay, this 2 number is a small number, then you can use Poisson. But if the number is big, then we go for normal. These are the condition for you to choose whether it's Poisson or normal, for you to do the approximation. Now let us go to the first question. Look at this. Please read yourself. Exercise in class 1. The random sample of n equal to 1600 tires is selected from an ongoing production process, which 8% of all such tires produced are defective. What is the probability that will be defective? Okay, first of all, x is number of defective tires. This is binomial distribution with n is and the question is this one. You can notice that n is 1600, which is greater than 30. NP is greater than 5. Okay, so it fulfilled the equation. Somehow is fulfilling the equation. Now, fulfilling the condition, not equation. Now, for us to find, for us to use what do you call, for us to use approximation. Okay, I write here by. For us to use approximation, normal approximation, we need to find the mean and the standard deviation. Okay, so the mean is actually, you can see here, NP. This is actually your mean. You already found that. And for variance, NPQ this is your variance, so your standard deviation would be this one. Leave it like this. Alright, now let us do the approximation. We know that mean is 128, variance is, and you see this one, when we want to do continuity correction, I go for the other part, next page. Now you can do as normal, do normalization. Standard deviation is 117.76. Do this 2.07. 2.07 is here. You need this part of shader region, therefore you need to find this one. And if you use the table, I suppose you guys know how to use the table. If you use the table, this part you will get 0.0192. so if I want to find the black color shader region, 1 minus, the answer is 0. That is the answer for this one. Number 2, try to read it. For overseas flight, an airline has 3 different choice on its dessert menu: ice cream, apple pie, and chocolate cake. Based on past experience, the airline feels that each dessert is equally likely to be chosen. Equally likely means they have equal probability. Yeah? So X would be let's say X is number of passengers like ice cream. X is binomially distributed with total is 90 passengers, and those who like ice cream is, since it's equally likely, how many desserts are there? 1, 2, 3. Total is 3. Ice cream is 1. So 1 over 3 is the probability. We want to do this by approximation. So mean is NP and variance is NPQ. NP we have done, so 31 minus this one, you get 20. A, at least greater or equal to 20 by continuity correction. Now do as normal. U1 is black shaded region, and you want to find this in your, if you find this would be nine 4 1 minus this would be the answer. For B, continuity correction. So if you want to find this, you have to find the green color first. the area of a green color would be 0.0170 minus the red color, that would be 0.0094. Answer is this one. For C, continuity correction from here. So that's how you do the approximation of binomial theorem, binomial distribution. Right. So with this, I would like to stop the class here for today. We finish until chapter 3. Tomorrow and the day after tomorrow is our tutorial. I will start with the new chapter, the one I share with you in the WhatsApp, correlation and regression. And I have given all the answers, full answers for all the tutorials until chapter 3. So you can check your working now. And tomorrow in the tutorial, I will give you some time. If you still don't understand anything, you can ask me, I will explain. With that, that's all for today. I'll see you all on Monday and Tuesday in our tutorial. Take care. Bye bye.
Thank you, Doctor.
Thank you.
Thank you, Dr.